welcome to The Explainer. You know how services like Spotify and Netflix sometimes feel like they can read your mind? Today, we're going to pull back the curtain and look at the magic behind how they know exactly what you'll want to watch or listen to or buy next.
So this quote right here, this is what a Spotify employee said during a super early test of what would eventually become Discover Weekly. And it just perfectly captures that feeling, doesn't it? That little shock of delight when a recommendation is so perfect, it feels like it was made just for you. But how do they build that secret twin?
You see, the success of Discover Weekly wasn't just about a clever algorithm. It was about brilliant product design. They took this really powerful, really complex technology and wrapped it up in something simple and human, a weekly mixtape. It created a habit, it gave you a sense of ownership, and it made this hidden tech feel personal and kind of magical.
So, how do they actually pull this off? Well, in this explainer, we're going to trace the evolution of this whole technology. We'll start with the early problems, look at the big breakthroughs that changed everything, see how neural networks took it to another level, and then explore what it all means for the future of discovery.
All right, let's start at the beginning. To really get how we got to today's incredibly smart recommenders, we first got to look at the foundational ideas where this all started. So, in the early days, things basically boiled down to two simple ideas. On the left, you've got content-based filtering. This is super intuitive, right? You watched a sci-fi movie, so here's another sci-fi movie. Simple. On the right, you have collaborative filtering, which is the classic, people who like this also liked that. It doesn't know why you liked a song, it just knows your taste overlaps with other people who liked a different song.
And here's the crucial question. These simple approaches have their limits. I mean, human taste is messy and complicated, right? What if you like sci-fi movies, but only the ones with a really dark, gritty feel? Or your music taste is some weird mix of 70s funk and modern electronic? Simple similarity just isn't going to cut it. And that's what led to a major breakthrough, one that was really popularized by the famous Netflix prize.
So this limitation, this problem, it's what led to the next major evolution in recommendations. And this is where things get really interesting, with a powerful technique called matrix factorization.
Instead of just looking at basic stuff like genre or what other people like, matrix factorization tries to discover the hidden dimensions of your taste. Think of it like this. It learns abstract qualities, things you can't just see on a label, like how synth-heavy a song is or how character-driven a movie is. It represents both you and every single item as a set of scores along these hidden dimensions. And to make a recommendation, it just has to find the items whose scores closely match yours.
But matrix factorization has a weakness. It uses a pretty simple way to measure similarity. It's basically drawing straight lines to connect tastes. And well, the real world is almost never that simple. This table, which comes from a really important research paper, it highlights a perfect example of where this simple, linear approach can get tripped up and just make a bad call.
So if you actually look at that data, user-forced tastes seem most similar to user ones. But because the model is limited to these simple straight-line comparisons, it gets kind of forced into a corner, mathematically speaking. It can end up suggesting things from users who aren't really a good match, just because it doesn't have the flexibility to understand the more complex, nuanced relationships. It's a rigid system trying to understand a very fluid human taste.
So, to solve this big problem of inflexibility, researchers turned to the exact same powerful tool that has completely transformed other fields like image recognition and language modeling, deep learning, and neural networks.
And the big idea is actually pretty elegant. Instead of using a rigid, predefined formula to compare users and items, what if you could just replace it with something that learns the perfect comparison function directly from the data? And that's exactly what a neural network does. It acts like a flexible, universal taste-matching machine that can discover any pattern, no matter how weird or complex it is.
This right here, this is the general blueprint for that solution. It's called Neural Collaborative Filtering, or NCF. Think of it like this. A user and an item go in on one side, they get turned into those taste profiles we were talking about. But then, and this is the key part, instead of a simple comparison, they pass through a series of learning layers. This is the brain of the operation, where the network figures out all the complex, subtle connections between them before spitting out a final recommendation score.
And this illustrates the next brilliant step. Instead of just throwing out the old matrix factorization model, why not combine it with a new, deep neural network? This model, called NeuMeth, does exactly that. It runs the simple, linear model and a complex, nonlinear model at the same time in parallel and then fuses their outputs together. It's like getting the best of both worlds, the reliability of the classic approach with the awesome expressive power of deep learning.
Okay, but all of these models, even the really advanced ones, kind of assume the system has a lot of data about you.
So what happens when it doesn't? What about when you're just browsing a new website for the very first time?
This is what we call the challenge of session-based recommendation. The system has to make smart suggestions based only on the clicks you're making right now in this one single session. It can't look at your long-term history. It has to understand the sequence of your actions and predict what you're trying to do in the moment.
And that's a job for a completely different kind of neural network, a recurrent neural network, or RNN. As you can see here, RNNs are built to understand sequences. With every single item you click, the network updates its internal memory, its hidden state. This lets it learn patterns from the order of your actions and make a really sophisticated guess about what you're probably going to want next.
So we've gone on this whole journey, from simple also-liked lists all the way to complex neural networks. Let's zoom out for a second and just look at the big picture of this evolution and what it all means.
We've seen a really clear path here. We started with those simple similarity rules. Then came the big breakthrough with matrix factorization, which let us uncover the hidden dimensions of taste. Neural networks then came along and supercharged everything by learning complex, nonlinear patterns. And finally, recurrent networks gave these systems the ability to understand what you want right here, right now.
At the end of the day, all of this complex math, all this data and engineering, it's all working towards one single goal, to create that seamless, almost magical feeling of discovery. It's all just in service of recreating that secret music twin experience, but for millions and millions of people all at once.
Which leaves us with a final thought to chew on. As these systems get even better at understanding the deep hidden patterns of our tastes, both as individuals and as a whole, what does the future of discovery even look like? Will they just get better at predicting what we want, or will they actually start shaping it? Thanks for joining this explainer.